Welcome back, everyone. We've already covered how to calculate variations for events with repetition. In this lecture, we are going to focus on events where we apply variations without repetition. Okay, let's begin. Imagine you are a track and field coach and need to choose which 4 members of your team run the relay and in what order. The team consists of 5 people: Tom, Eric, David, Kevin, and Josh. And you must decide who starts, who anchors, and who runs in between. Okay, we have 5 members in the team, which means 5 different scenarios for who we want to start. Let's say we know that David is the best guy for the job. That decision leaves us with only 4 options for who gets the second position, namely Tom, Eric, Kevin, or Josh. Suppose we chose Josh to run after David. That leaves us with only 3 options for who runs third: Tom, Eric, or Kevin. Now, if we pick Kevin, then we know one of either Tom or Eric finishes the race. Not surprisingly, if we chose Eric to run third instead, we once again have 2 choices for who runs last: Tom or Kevin. Finally, if we choose Tom to run third, we would have 2 options available: Eric and Kevin. This means we can have 6 different variations for who runs the last 2 positions if we have chosen David and Josh to run first and second, respectively. Using a similar logic, if we pick somebody different than Josh to run second, we would still have 6 possible variations for who runs third and fourth. In fact, regardless of who out of the 4 members of the team we chose to run second, we would always have 6 options for who fills out the remaining spots on the team. That suggests there are 4 times 6, or 24 different ways to arrange the 3 remaining positions if we knew David starts. What if we aren't sure that David is the best runner to start? Well, if somebody out of the remaining 4 people started, we would still have 24 ways of filling out the remaining spots on the team. What happens is, the further down the order we go, the fewer options we are left with, since nobody is permitted to run multiple legs. This is what variations without repetition is about. We cannot use the same element, or in this case, person, twice. In terms of numbers, we have 5 times 4 times 3 times 2. This makes 120 different options of how to arrange our team for the competition. That wasn't too bad, right? It's time to introduce you to the formula for calculating variations without repetition. The number of variations without repetition when arranging p elements out of a total of n is equal to n factorial over n minus p factorial. Applying this formula to our example, the total number of variations without repetition would be equal to 5 factorial over 1 factorial. Using the properties we introduced in the bonus lecture about factorials, this is equal to 2 times 3 times 4 times 5, which equals 120. All right, let's wrap up here. As usual, please go through the homework exercises and try answering all the quiz questions. Thanks for watching.